Morning students, how are you? Have you completed the DC windings and single phase windings which we have learned previous classes? Have you completed it? Okay, then we will enter into the some more difficult part, that is the three phase windings. Let us recollect what we have seen previous classes. So, electrical winding. Now, what is this one? This is a DC machine. We have seen a DC machine windings also, the single layer, a double layer, lap windings and wave windings. As comparing to the DC windings, DC motors, we have some advantages. Hence, we preferred AC motors. Hence, we have learnt how to draw the lap winding, wave winding in single phase in AC motors. Okay. So, that is why we preferred types of AC motors. So, you can see these AC motors, the easy friendly machines, these are available in surroundings, domestic and industrial purposes. So, what are this one? You can see at a glance the types of AC motors. So, these are the different types of AC motors available, whether single phase and three phase. Now, you can observe these all are available in nearby domestic areas. To pumping the water from the municipality water sump to overhead tank, we require the single phase, split phase induction motor. To run our desert cooler, we require the pump as well as the fan. Ceiling fan also single phase motor, and the mixer also single phase motor. Everything, so all are operated in a AC supply. That is why we preferred comparing to the DC motors. At a glance, what is the difference between main AC motors and DC motors, as we discussed previously also. So, but as electrical students, we should know always. As we know that while both AC and DC motors serve the same function of converting electrical energy into the mechanical energy, they are powered, constructed and controlled differently. The most basic difference is the power sources. AC motors are powered from alternating current AC from generating stations, hydropower station, thermal power station, nuclear power stations and diesel engines also. So, just we have observed in front of malls, shops. Okay. So, now whereas in case of the DC, while the DC motors are powered from a direct DC source such as batteries, DC power supplies, generators, or we can use the AC to DC converters, rectifiers. Okay. So, now these rectifiers also we have observed in our DC machine laboratory. And DC owned field motors are constructed with brushes and a commutator, which add to the maintenance also, limit the speed, and so what will happen if the speed is more, the brushes which are on the commutator, there is a possible to spark. You can observe this situation in case of trains having the one fan. If it rotates, you can observe that the commutator, there is a spark may be observed. So, that is a limitation. The speed as well as usually reduces the life expectancy of brushed DC motors. Wherever the brush is available, automatically the life brushes, whether carbon brushes or copper brushes, the wear and tear, the maintenance is required. But in case of our AC induction motors, do not use the brushes. They are very rugged and have the long life expectancies. So, mainly the basic difference is the speed control. The speed of the DC motors is controlled by varying the armature winding or field winding. We have already done in our laboratories. But in case of our AC motors, we can easily controlled by varying the frequency. But in case of the DC, there is no frequency. So these are another advantages of AC machines. Hence, so we preferred mostly the wherever we required cheap and best our AC motors. Motor. So how big it is? It is a large size 3-phase induction motor for the special purposes in our industries. In last class, we have also seen the single phase AC motors, how the lap winding for the single phase wave winding, how the lap and wave windings for our single phase motors. Now, so there is a difference between the single phase motors and 3-phase motors also. What is the main difference? The single phase alternating current is the most common source of power used by the most households and non-industrial businesses, just like its domestic purposes. Whereas in 3-phase AC motors is particularly common in large businesses, including in the manufacturing of goods and also the industrial businesses. The efficiency of 3-phase operated devices and appliances is higher than the single phase operated machines. 3-phase machines are less costly and more efficient comparing to the single phase motors. Hence, so we preferred 3-phase motors only. Hence, we have to learn how to draw 3-phase motors armature winding, whether it is a lap winding or wave winding or single layer and multi layers. Okay, let us see few more motors of induction motors. Then we will take the one particular problem and we will complete the how to draw the windings. Okay, let us see. So here the 3-phase motor includes the synchronous machine also. What is a synchronous machine? So this machine can be used as a motor as well as generators. In case of the generators, it is used in our power plants like Nagarjuna Sagar, Srisailam projects and any nuclear power station, thermal power station, hydro power station, anywhere that is a 3-phase machine, or induction motors, that is also 3-phase machine. And motors, synchronous motors can be used in the industries to improve the power factors. Already we discussed in last classes. Okay, so induction generator, so that is used in windmills. So these all are 3-phase motors, AC motors. So we require to know how to draw their windings. Okay, so let us see another. This is a comparison between the AC motors and DC motors. Our last class we have seen. So here mainly, so in DC motors, if you are observed, this one drawback is a commutator, another drawback is the brushes. So in our business, there is no brush and commutator, only armature is the stator part. In this case, armature is the rotor part. Speed control also is only speed control 2 methods, but in case of we can control the speed of the AC motors by pole changing method, frequency method. So as we know that the speed, that is a formula, N is equal to 120 F by P. That means the speed can be changed by changing the frequency, by changing the number of poles. But whereas in this case, no changing of the frequency business. Okay. So these are some differences already we discussed previous classes. Now let us see the 3-phase lap winding. Okay. So before going to the one particular case study, so let us recollect once again what is the lap winding. Okay. So here you can see it. What is the lap winding? As you know that Hanuman tail story once again. A lap winding is a winding in which a successive coils overlap each other each other. That means, so this is the one coil and coming and overlapped, coming and overlapped, coming and overlapped, coming and overlapped in progressive winding. Okay. So, it is named as a lap winding because it doubles or laps back with its connection. So, you can see, observe, in case of there is a two coils, so green coil and red coil. The coils consist of, green coil consists of two conductor sides. Here the coil sides. So, one is placed here, you can see this is under north pole, one coil side. From back pitch it is placed nearby, so south pole and the slot at a back pitch. Now, once again it is coming to the connected to the second coil here, red coil with the front pitch. Now, once again it is going to the connect the second coil and the two coils placed 120 degrees, that is 180 degrees apart, the pole pitch is connected here. So, that is a routine lap winding. Dear students, you can see these are the how this number of, so you can see this is the winding are connected. This is the first slot is going to connect to the one pole pitch. Okay, it is connected to this one. So, you can see the number of slots, windings connected. Okay, you can observe here. These are the slots, these are the coil sides, this is the back pitch, here is the front pitch. Okay, so that is already known. What are the different of the slots used in AC and what are the coils also used in our field, electrical field. So, that is also we are going to recollect it. Now, this is the one motor, armature, stator, armature. It consists of the stator core. The core is made up of the silicon steel material. It is also laminated to reduce the eddy current losses, and it is added some silicon content to reduce the hysteresis losses, the stompings. Okay. So, these slots may be, so as we discussed previously, it is a open slots, semi closed slots or closed slots. Okay. So, you can see this here is a, so already we discussed this is a open slots, whereas, so this is a semi enclosed and these are the closed slots. You can see here this one slot. So, here semi enclosed and this is the closed slots. So, in slots there is a 4 coil sides inserted here, quadruplex winding. Okay. So, these are the one example of slots. Now, what are the windings? How the copper winding at different shapes? The coils may be diamond coils, it may be, so how they are connected, end connections with the help of the some insulating paper insulations, cotton insulations. So, different type of the coils, you can see that is also here. So, what is this one? The base coils. So, winding base coils, how they are connected, you can see it, and insulation, how they are insulated. So, coil side to side, you can see it, and side you can see in the third figure, you can get the elevation and side view, diamond coils, and how these coils are inserted in armature core, you can see here. Okay. So, these are the practically how these coils and how we are going to insert in our slots. Okay. So, let us discuss our AC 3-phase winding. So, as we discussed previously, single phase winding only having the, so starting and ending, the starting act as a phase and ending as a neutral. So, single phase supply phase neutral 230 volts is enough, but whereas the 3-phase winding circuits we require the 3 phases, R phase, Y phase, B phase. What are the advantages we discussed just now? Okay. So, how this windings placed in the circuit? Already we have seen the AC windings are maybe different types of windings. Okay. So, we discussed previously mainly distributed windings and concentrated windings. So, whereas a distributed winding there is a rotating magnetic field is developed, whereas a concentrated winding there is no rotating magnetic field is developed. For example, concentrated winding is for the transformers, you can see that is also one example. Okay. You can see here. So, one is the concentrated winding, this winding. So, this type of the winding is used in case of our 3-phase transformers, where it transforms the energy from the primary circuit to the secondary circuit. Okay, so if this is a concentrated winding, phase 1, phase 2, phase 3, so you can see here. Now, whereas a distributed winding, it has a number of slots on the core, and these slots are placed so side by side. So each slot phase angle we have to calculate, and R phase, Y phase, B phase, that should be placed at a 120 degrees apart. Phase displacement is must here. So that's why you can see this black color is a one phase, and ash color is another phase, and orange color is another phase, placed in a side by at a phase sequence manner. Okay, so let us see that is how this connected, and end connections how we are going to taken out from this one, where the in single phase and three phase we can see it. So here you can observe this. The phi 1, phi 2, phi 3 are the fluxes developed while current is passing through these windings. For example, in this first case you can see it, the two pole machine, slots are 12 slots, a three phase winding is owned. Here what is happened? Only two persons. So his father is given the 12 apples. So each one share nearly 6 apples to each other. So north pole under influence of 6 slots, and south pole in influence of 6 slots. You can see here. So they taken connections. You can see three phase supplies here. At the same time, you have to remember that here. So each phase, R phase, Y phase, B phase. Now we have to take it consideration how many slots for each phase. That means already we discussed M. So that is the number of slots for pole, 2% for phase. So here three phase supply, machine, 4 pole machine, number of slots. So that means, so here we are going to apply that M is equal, here number of slots is a 12, and number of poles is equal to 2 poles into number of phases, 3 phases. 3 ones are, 3 fours are, 2 ones are, 2 twos are. That means, so here the number of 2 slots per pole per phase. So R phase, Y phase, B phase, 3 brothers. So each has to allocate 2 rooms. So R phase 2 slots, Y phase 2 slots, B phase 2 slots under one pole simultaneously, and same sequence under the south pole. Okay, so that is a phase sequence in case of 3 phase. So dear students, please remember these things. For example, in case of 4 pole machine, you can take the another example. Here what is the M? So you calculate the here slots is equal to M is equal to number of poles. How many slots is it? 24 slots is given, divided by how many poles? 4 poles is given. How many phases? 3 phases. Okay. So here you are going to calculate. So 3 ones are 8s are, 4 ones are, 4 twos are. So here also 2 slots for each phase. That means R phase, Y phase, B phase under north pole, 2 slots for this one, 2 slots for this one, 2 slots for this one. Okay. So here, so these slots, whereas at the same time south pole under this one, 2 slots, 2 slots, 2 slots. Next 1, 2 and another north pole. So here is also slots. Okay. Under this also, so these slots, such a way that we are going to distribute these slots. Okay. So 3 phase, so we are going to distribute total slots equally to 3 brothers, R phase, Y phase, B phase brothers. In same manner, we are going to maintain the phase sequence 120 degrees each other. Okay. So that is an interesting topic, dear students. Just you remember this. Okay. So let us don't confuse. I will explain later with one small story. Okay. Let us take the one how we are going to draw the winding. So what are the steps? Similar steps. The single layer lap winding. For development of the simple layer lap winding, so let us take the one case study. So what is this one? The case study is this one. So we will take the, instead of single phase with 3 phase we taken. number of poles, 4 poles is taken. Total conductors or slots, we taken the 24 slots or 24 conductors, and lap winding and progressive winding. These are the case studies we are going to do. So any winding, so we have to follow the some steps, 1, 2, 3 steps we have to follow. Okay. In DC, so another 2 steps, we have to connect the commutators, we are connect the brushes. Here there is no problem of commutators and brushes. Now what are the steps? So as usual, so first step is the simple, the calculation for so pole pitch, what is the back pitch, what is the front pitch. Okay. After knowing the simple calculations, then prepare the so a winding table based on the back pitch and front pitch. Okay. So here in addition to the winding table, we are going to so make it another one simple table that we can say is a conductor distribution table. Okay. Here we are going to so make it, to avoid any confusion, make it the how the conductors are distributed in a slats. Okay. Here are 3 phases, and last one, after knowing this one tables, so develop the winding diagram with the help of the winding table and that table. Okay. So these are the steps, dear students, as usual same. So here in addition to that one, so winding table, we are going to use another distribution table. Okay. So these steps. Let us do simple first step. What is the simple calculation for the pole pitch RYB? Okay, for a simple case study. What is the simple case study? So he is given the 4 pole machine, conductors 24, lap winding, progressive winding. Okay, so let us calculate some simple calculations. Now, what are the salient points of lap winding? So as we know that lap winding, so here the back pitch equals to the pole pitch, and back pitch and front pitch differ by 1. As we know that the back pitch is minus 1 is equal to front pitch, and resultant pitch is equal to back pitch minus the front pitch in case of progressive winding. These are the some salient points regarding to the lap winding. So let us do the some simple calculations regarding to the given case study. Okay, let us see. Now here what is the question is given? Lap winding, 3-phase lap winding. So number of poles, P is equal to 4 poles, number of conductors 24 conductors, and progressive winding. So we require to find that what is the, first of all, what is the YB and what is the YF. Before that one, we are going to the what is the pole pitch. First of all, pole pitch we have to find it. Okay, based on these calculations, based on the given data, we are going to calculate what is that one. Now find the pole pitch. The pole pitch is equal to, what is the formula? So total conductors by number of poles. So what is the conductors is given? 24 conductors, and number of poles, 4 poles is given, 4 ones are 4 6 are. So 6 is a pole pitch. Now in case of 3-phase machine, so we are going to calculate M. What is a M? So number of slots per pole for phase. Each phase, under each pole, how many slots we have to allocate, that is required M. What is that one? M is called number of slots by pole per phase. So we require to find that this M is essential. Now based on this one, so what is the number of slots is given? 24 slots is given. Here the single ear winding. Okay. Now what is the number of poles? 4 poles is given, and number of phases, how many phases? 3 phases. Okay. Then we are going to calculate. Okay. 4 ones are 4 8. So 3 ones are 8. 4 ones are 4 twos. Okay. So we are going to get it nearly 2 conductors. Okay. That means each phase under influence 2 phases, 2 slots only. Okay, so here, so we calculated this one. Now after that, so we are going to calculate. Now after knowing the EM, so find that what is the back pitch. So generally the back pitch is equal to pole pitch. Okay, so we taken here, consider that is equal to, so what is the value? 6. So back pitch is equal to 6. Then so we know the formula, the front pitch is equal to, so YB minus 1. What is the back pitch? So back pitch is equal to 6 minus 1. So we taken this is equal to 5. Hence, so therefore we know that what is the back pitch is equal to 6, and what is the front pitch, that is equal to 5. So based on this one, so we are going to prepare our winding table as usual. Okay, so here, so this is the one basic idea. So before going this one, so we require to distribute these windings under 3 phases: R phase, Y phase, B phases. Okay, so let us see animation once again. Okay, this is question is given now. So we require to calculate the what is the pole pitch, back pitch, front pitch. So pole pitch formula is equal total conductors by total number of poles. So we are going to get is that is equal 6, and M here going to calculate, that is the number of slots per pole for phase, that is equal to 2, and so we equated the back pitch is equal to pole pitch, that is equal 6. Then after knowing the back pitch, we are going to find that what is the front pitch. So by applying the our basic formula, then so we are going to get it. So what is the back pitch, what is the front pitch? So dear students, here there is a one important thing should remember. So that is the here main thing is the this one. So M. Okay, that means here what are the number of poles? So we discussed previously. So this 4 poles. Okay, so north pole, south pole, north pole, south pole. So here 6 slots, 6 slots, 6 slots, 6 slots. Now, so as for this one, 2 slots for R phase, and here south pole under influence of 2 slots, north pole also 2 slots, and south pole also 2 slots. That means for R phase we are going to give the number of coils. So that means here R phase we are going to, out of 24 slots, so we are going to give it, so here 8 slots for R phase. So that 8 slots is distributed under north pole 2 slots 1 and 2, and under south pole so 2 slots, under north pole another 2 slots, under south pole another 2 slots at a pole pitch at a 180 degrees between the north to south poles. Similarly, so Y phase, so it is also required the 8 slots. After that, so we are going to the 2 slots here, 2 slots here, 2 slots here, 2 slots here, and B also 8 slots. So 2 slots, 2 slots, 2 slots. So that purpose I am going to tell you one small story. Let us see that one. So let us here you can observe. So here one is the landlord. He has the 3 sons. Okay, so he has the more properties. Let us take one. He has the properties in Delhi, he has properties in Calcutta, he properties Chennai, and also in Mumbai. Let us assume this industrialist having the 6 cottages or rooms and houses, flats in Delhi. Equally he constructed for his sons 6 houses in Delhi, same 6 houses in Calcutta, 6 houses in Chennai as well as in Mumbai. To avoid any disputes among the 3 members, you want to share his property. So, you can see, otherwise what will happen, there is a quarrel in each other, hence he decided to distribute his property, assets to his sons equally. So, let us take first priority is given to the younger son. So, for example, take the in Delhi properties. So, he has the Delhi properties. Second is the 1, 2, 3, 4, 5, 6 houses. Okay, he want first is given the asked the his younger son. So, he chooses the first and the second two houses he selected. Next, second one is selected the 3 and 4 houses, and last one is selected 5 and 6 houses, equally distributed 2 houses, 2 houses, 2 houses in Delhi given to the 3 sons. Okay. Similarly, he has given the Calcutta also the same 6 houses. Next, Chennai also 6 houses, and Mumbai also distribute the same houses, same construction. Okay. So, this way in our 3-phase winding also we are going to provide. Okay. So, do not confuse, dear students. What is happened? So, here first son, this one son is given the 2 houses in Delhi and 2 houses in Kolkata, 2 houses in Chennai, 2 houses in Mumbai. Similarly, this also given the 2 houses and 4 different places. He also given the 2 houses, 2 houses, 2 houses, 2 houses. So, sequentially is given. So, because first priority is given the younger one, after that this particular. So, the elder one is given the last priority, that is the 5 and 6. So, instead of houses we assumed as a slots. Okay. So, this story you have to remember while distributing the conductors. Okay. Let us see that one. So, now here in case of the, suppose if there is a 2 poles, only 2 sons, what will happen? So, you can see here. For example, number of poles is 2, slots are 12 and phases are 3 phases. What is the M? So, I am going to calculate M is equal to number of slots, okay, by number of poles by number of phases. Okay, that is a M. So, what is the slots? 12 slots divided by, so 2 poles into 3 phases. 3 ones are, 3 fours are, 2 ones are, 2 twos are. So, M also we are going to 2. That means here north pole and south pole. So, what is the pole pitch? So, pole pitch is equal, pole pitch is equal, what is the pole pitch? How many poles? So, total 12 slots by 2. 2 ones are, 2 6 are. So, 6. That means, so under north pole 6 slots, 1, 2, 3, 4, 5, 6. Under south pole 6 slots, 1, 2, 3, 4, 5, 6. Okay. So, equally distributed under one pole pitch. Okay. At the same time, so 2, M is equal to 2, that means, so here are the R phase, Y phase, B phase, 3 suns. So, this sun is given the 2 rooms under the north pole. At the same time, under the south pole, this is a, for example, this is a Delhi, this is a Calcutta. Okay, only 2 places here. So, north and south, 2 poles. So, at the same time, 2 under the north pole and 2 slots under the south pole. So, you can see, so red color 1 and 2 is designed for the R phase, and Y is given for the 3 and 4 slots. At the same time 9 and 10 here, and B phase is given the 5 and 6 and 11 and 12 slots. So, this connection you can see here. So, if it is connected here, you can see this how they are the connected. So, this is the 1 person, this another 2 person, this another 2 person, under influence of this one pole, under influence of under this pole. So, 2 coils, 2 slots, 2 slots, 2 slots, we connected such a way that. Okay. So, this is the distribution of our coils in a slots. So for example, instead of P is equal 2, if P is equal 4, how we are going to distribute these coils? Okay, let us see that is also. Now here three phase system. So you are going to remember one thing. What is that one? In three phase windings, so here before three phase winding here, so let us assume single phase winding. So what is happened? Single phase, this is a phase and this is a neutral. Well, phase and neutral 2 will come. So there is no problem here. So what will happen? If I connected the any load here, simply it is connected to the this one. So coming the current and so 180 degrees apart this one phase displacement. But whereas this one single person, only one person here presents single person. So whatever the property is given to the total this person. But whereas in three phase, what is happen? In three phase, so here there is a sequence of R phase, Y phase and so R phase, B phase, Y phase. Generally we represented the phase sequence. Okay, the phase sequence is required. So in any three phase winding, the total number of minimum slots that can be taken for pole is 3 phases, that's why. So there will be phase differences of 60 degrees between the two adjacent windings, slot to slot. When the three phase windings are start from the slot number 1 and 2 and 3, but what will happen? The three phase, the phase angle between the two adjacent windings must be 120 degrees, but here the R phase, Y phase, B phase, so only 3 slots for each one, for example, so only 60 degrees is available. So this can be achieved by the reversing the connection of third winding. So we are going to get that instead of so R phase, B phase, Y phase as usual. So I reversed this one. So we exchanged the B is coming here and Y phase is coming here. That's why, that means instead of going this one, so here phase 1 and phase 2 and phase 3, so 120 degrees apart each other. Okay, that means the slot 1 is allowed to the, for example, one machine having the only 3 slots for each north pole. So that first phase is given the first slot and the second one is given the third slot. So because for example this is a 3 slots, 60 degrees plus 60 degrees plus 60 degrees. So what will happen? We require the 120 degrees. So R phase is given the 60 and remaining, so second phase is given to the, so here third slot. So 60 plus 60, 120 degrees apart. So we are given the third slot for the second winding and third one is given to the, and this one, instead of going this one, a reversed connection, we connect in the reversed connection. So such a way that, so we exchanged here. So dear students, don't confuse R, Y. So here I create the R, Y, B. So actually, so R, B, Y, this is a phase sequence. So 120 degrees apart. So instead of that one, so I changed, what will happen? R, Y, B, phase sequence changed. So you can see clarity here. You can see, so as usual, this is the normal phase sequences. To create the 120 degrees apart among the 3 phases, I exchanged the B and Y phases, you can see here. That means here the in first slot phase 1 entered coil here, and in third slot, so we are going to the here the second slot. So we are connected to the B phase, but the current is coming downwards. That is the starting here, the ending here. Reversed that one. Okay, just like we reversed this one. And as usual, so B phase is entered here. So that is you have to remember. Already you learned in 3 phase system also. Okay, so this is the one thing you have to remember. Now after knowing this one, let us see here. So what will happen? So there is a 4 pole is given. Slot 24, 3 phase winding is given. Here 4 slots. So what we have discussed here previously, this is Delhi, this is Calcutta, this is Chennai, this is Mumbai. So under each place, so how many slots? R phase having the two houses, Y phase has the two houses, and B phase has the two houses. Similarly, 180 degrees apart and pole pitch. Okay, so here pole pitch same, so red, Y and B. At the same time, so north pole also two slots, and here also two slots. So for easy understanding purpose, so let us draw first R phase. We will distribute the total coils, okay, under all poles. That means here 4 poles. So what is the R phase? So here 2 slots, then you are going to the 2 slots, you are going to the 2 slots, under 2 slots, under 2 slots, R phase. Next, under Y phase, so this Y phase, we are going to the 2 slots, 2 slots, 2 slots, 2 slots. Okay. Next, B phase. So 2 slots and 2 slots and 2 slots, 2 slots, such a way that we can do. Okay. You can see here. So what is happen here? For example, you can take the R phase. So what will happen R phase? So we entered here. So we completed. We will go here, and entered here. We will complete here. Entered here. Complete here. Entered here. Complete here. This is the ending. This starting. The coil is, so this is the lap ending here. So it will entered, back pitch. So this is entered, leaving here under one pole. Similarly, here also same. Similarly, here also. Similarly, here also. That means, or so 2 slots, 2 coils, 2 coils, 2 coils, 2 coils. Total 8 coils R phase over. After that, you are going to connect Y phase. So here Y phase we are going to connect is the insert the coil here and coming here, insert the coil here, coming here, insert the coil here, coming here, insert the coil here, coming here. But actually you have to give the connections from here supply. So what will happen? So it will come this direction to create the 120 degrees apart. This is a finishing one to maintain the phase sequence. Okay. After that, so B phase. B phase is a, so this one entered here. Okay. It's a 2 slots coming here, 2 slots coming here, 2 slots coming here, and 2 slots coming here. This is a, so here you can say 3 phase. This is a starting winding, this is a ending winding. But at the time of the connection, you have to give the, these are the 2 supplies input. Here is the Y phase is the input. So this is a flat. If you have the made is a round armature, you can see here connections. All these connections you can see the R phase 2 slots. Okay, the 2 slots, this 2 slots. So this is one pole. So this is another pole. This is another pole. This is another pole. How the windings is distributed. Okay, so this is a basic concept, dear students. Now practically you can see how they are connected. You can see here this R phase coils. So 3 coils here are connected here. Y phase coils is connected. B phase coils is connected here. Okay. So practically how these coils are connected. So represented based on the this table. Okay. So don't confuse. So the simple winding. So based on this basic concept, let us make one conductor distribution tap. Okay. So that means whatever the property, how many rooms, how many plots, how many assets you have to distribute among your 3 children equally, but you have to maintain the 120 degrees apart. Okay. So you have to give the proper 120 degrees apart means you have to maintain the moral. First you have to give the priority to the younger one, after that middle, after that elder one. That is the we are going to maintain the 120 degrees apart. Okay. So this is a basic concept. Now let us start on the conductor distribution table. So what is the distribution table here? So how we are going to connect? How many total? So 24 slots. Okay. So here 3 phases. 3 ones are 3 8s. That means 8 slots each phase. Here 1 phase R phase, let us assume Y phase and B phase. So we are going to distribute equally, total 24 slots. Okay. So, here what will learn, 1 and 2 is given here, 3 and 4 Y phase, 5 and 6 another phase. One round is over. Next 7 and 8, 9 and 10, 11 and 12, 13 and 14, 15 and 16, 17 and 18, 19 and 20, 21 and 22 and 23 and 24, simple distribution of this one. Okay. So, you can see, dear students, simple substance. That means here you can see this is the one pole, this is another pole, is another pole, this is another pole. Okay. So, here similarly the phases, each phase, suppose for example 2 coils, here 2 and 2 slots, 2 slots, this 2 slots, 2 slots. For example, the north pole, south pole, north pole, south pole, such a way that we connected. Okay. So, 1 and 2 slots or phase, 3 and 4, 3 and 4, 5 and 6, 5 and 6 under one pole. Next another pole pitch, 7 and 8, 7, 8, 9, 10, 9, 10, next 11, 12, 11, 12 another phase. Next another pole similarly here, another pole similarly here. Okay. So, this is a simple distribution table, dear students. Okay. Now, after knowing that this one, so we are going to make the winding table. Okay. So, let us do the winding table. So, you take the one practical example how these slots are allotted for each phase and under each north pole, south pole, north pole, south pole. Okay. So, you take the how the slots, how you are going to 2 slots one phase, 2 slots another phase, 2 slots another phase under influence of one pole, such a way that we are going to produce this another pole, another pole, another pole. So, practical. Okay. So, now let us make one winding table similar to the previous case. Now, so second step is the preparation of winding table. So, based on the back pitch, this one, based on the front pitch, we are going to make it. Okay. So, let us see that one. So, here you can see the divide the phase 1, phase 2 and phase 3. So, for the here you can see, so phase 1, phase 2, phase 3 to maintain the 120 degrees apart phase frequency. Okay. So, we discussed. Now, so back pitch and front pitch, in case first back pitch I started the start conductor 1. Okay. So, let us do that one. So, we will do manually. What is the time? 48. That's a long thing. Okay, we will do table here you can see. So, let us take this one. So, first we started in the phase 1. Okay, this is a phase 1 started and phase 2 and phase 3. Let us complete phase 1. So, phase 1 or phase, let us assume phase 1 or phase. So, what are the slots? In first case 1 and 2 slots and 7 and 8, 13 and 14, 19 and 20. These are the slots distributed among the under the each pole. Okay, let us start the at under one slot. 1 I started and completed the back pitch 6, that is equal 7th. I will go to the 7th slot here. So, 7. Then 7 minus front pitch I am going to get it. What is that one? Second. Yes, second is as my slot. I will go to the second. Okay. Then 1 and 2 is completed here. Okay. So, 1 and 2 completed. Now, 2, so plus 6 is, what is the value? 2 plus 6 I am going to connect it 8th. So, 8th is also mine. So, here I am going to connect the 8th. Okay. So, 8 plus here, so I am going to connect 8 minus 5, that is going to the For example, 8 minus 5, I am going to get what is the 3. 3 is not belongs to my face or face. So, it is belongs to the y face. So, we do not want to enter other domain. So, here I am going to go one pole pitch. So, that is why instead of 8 minus 5, dear students, simple 8 plus 5. This is the one twisting point you have to remember. Okay, then I am going to 8 plus 5, I am going to get the 13. So, 13 slot, yes, that is mine. Okay, so 13 slot is over. Next, so I am going to connect. So, 13 plus 6, one back pitch. So, what is the value? 19, yes, 19 also mine. 19 minus 5, what is that one? So, I am going to 14, yes, 14 also, what is this 14? 14 slot also mine, okay na? Yes, this is 14 slot is mine. Now, after 14, so 14 plus 6, so I am going to get is a 20th, yes, 20 also my slots. So, this is a 20 is a finish. So, you can see here, dear students, so what are the slots you can see here. So, see, so first slot 2, 1 and 2 is completed, you can see. Okay, so 1 and 7 is completed. Next 2 also completed and 8 also completed. Next 13 also completed, 19 also completed, 14 also completed and 20 also completed. How many slots? You can count it 1, 2, 3, 4, 5, 6, 7, 8. Yes, 8 slots we completed under influence of our phase. Okay, so here given the connections. Okay, so similarly you calculate another. So in case of the just in case now you connect to the B phase. So here connect to the Y phase. Okay, so what has happened? So I am placing the third conductor. Okay, so third conductor I am going to place 3 here. I am starting 3 plus back which is 6. I am going to the 9. Yes, so where is the 9 is my. Okay, so 9 minus 5, what is the value? 4th. So 4th is also mine. Next 4 plus 6, 10. Yes, 10th is also mine, belongs to the Y phase. Okay, so now 10 minus 5, we are going to get the fifth slot, but fifth slot belongs to the B phase. We do not want to enter the other domain. So here we have to go the one further step, plus you add it plus 5, so 15. Okay, so 15 is mines, dear students. Okay, now the 15 minus 6, so we are going to get that, what is the value? 15 plus no, so back which no 15 plus 6, so we are going to get the 21. 21 is a mine, this is a 21. Next 21 minus 5, so I am going to the 16, yes, 16 also mine slot. And 16 plus 6, so I am going to the, what is the value? So 22, so 22 is also mine. Where is the 22? This is the 22. So this 22 is a finish coil. So 8 slots is over. Similarly, you calculate here also. Okay, start from the 5th slot. Okay, so 5 plus 6, what is the one? 11. Yes, 11 is over my. 11 minus 5, I am going to get a 6. Yes, 6 is mine. So 6 minus, okay, 6 plus 6, 12. Yes, 12 is also mine. So 12 here you have to step, take the 12 plus 5. Okay, so what is that one? 17. 17. Okay, next as usual 17 minus plus 6, so I am going to do the 23. Yes, 23 is mine. 23 minus 5, 18, so 18 is mine. and 18 plus 6. So, what is that? 24th. Yes, that is the finishing. Such a way that, dear students, don't confuse, just you prepare the winding table. Okay. So, these are the winding table for 3-phase system. Let us see animation also. First phase. Okay, that is R phase, Y phase, B phase. We take in the first phase. After that, the second phase. After that, 3 phase. Okay, so but the connection is just 120 degrees. So we take in the starting from the 1 plus 6, that is 7, 7 minus 5 2, and 2 plus 6 8. Here 8 plus 5, instead of 8 minus 5, we are taking the 8 plus 5, 1 pole pitch we taken 13. 13 plus 6 19, 19 minus 5 is 14, and 14 plus 6 is 20, 20 is the finishing. So 8 conductors, 8 slots allotted under R phase, under 4 poles. Similarly, the phase 3, so we connected. So here slot 3 is allotted for this one, and 3 plus 6 is a 9, 9 minus 5 is equal 4, 4 plus 6 is equal 10, 10 plus 5 is equal 15, 15 plus 6 is equal 21, and 21 minus 5 is equal 16, and 16 plus 6 is 22, 22 is the finishing. Now here under the 22 coil we have to entered, and 3 we have to leave it. Here actually what is happened? So third is the finishing, so 22 is the starting entering current. Okay. So now coming to the phase 2. In phase 2, so we connected the 5 is allowed to 5 and 6. So 5 plus 6 is 11, 11 plus minus 5 is 6, 6 plus 6 is 12, 12 plus 5 is equal 17, 17 plus 6 is equal 23, 23 minus 5 is equal 18, and 18 plus 6 is equal 24, and 24 is the finishing. So these are the winding table, dear students. Okay. After knowing the winding table, so we have to prepare third step. What is the third step? So develop the winding diagram with the help of the winding table. Okay. Based on the distribution table, based on the back pitch and front pitch, we have made winding table. So just based on the winding table, just you as usual connect the end connections. Okay. Let us see. So this is the development of winding diagram with help of winding table. So here, so as usual, what to do? So you have to connect all, you have to draw all lines parallel to each other. Okay. As usual, just simple to draw the solid lines of equal length and equal distances and equal to number of slots drawn. Okay. So arbitrarily assume north pole and south poles as usual, and show the direction also. So this is a routine work, dear students. Now, so this is the first step. After that, we are going to, based on the winding table, we are going to connect it. So bring nearby our winding table. So this is a winding table. So based on this one, we are going to connect. So we are going to connect. Let us see. So in first, so we started from 1. So 1 connected the 7th. 7 is here. We connected 7 R phase. 7 is connected to the second. So coming to the front pitch, second is connected here, and from second to we are going to connect where second is connected to 8th. So this is 8th. Okay, 8th slot is over. So second 8 is over. 8 to 13 we have to, so because side by is the another phase. Okay, so because you can the red phase you can see, and we are going to connect here, entered here. So 13th, 13 is connected to 19th. Yes, so 13th is connected to the one pole pitch, 19th. So 19th is once again connected to the 14th. So this is the 14th. So 14 once again connected to 20th. So 20th is the finishing. This is this one. Sorry, dear students. What happened? So here Yeah. So here what will happen? 2 slots for year and 2 slots for year, 2 slots for year and 2 slots for year. Completed. No problem. Now coming to the another phase. So you can see Y phase. So Y phase, you have to start, give the connections here. Okay. So what is that one? So you have to start the third. Okay. This is the third conductor connected to the ninth conductor. So you connect to the ninth. Where is the ninth? This is the ninth. Okay. So 9 should be connected to the front pitch. How much? So fourth one. Where is one fourth? This is the fourth one. Okay. So 4 is connected to where? 4 is connected to 10th is over. Okay. So 4 is covered. 10th. We are going to connect the 10th coil. This is the 10th. Okay. This 10th. And 10 plus 5, we are going to connect the, so another domain area here. So what is that one? 15th. Okay. So the 15th is connected to 21. Where is this one? This is the 21. Okay. Now the 21 is connected to the 21 is connected to the 16th back pitch. So connected the, where is this one? 16th. Okay. Now the 16th is connected to 22. Where is 22? This is the 22. Okay. So this is a finishing coil. Okay. You can see 2 slots, 2 slots, 2 slots and 2 slots is enough. Okay. Now coming to the another phase, B phase. So what are the slots? We selected fifth one. No? So where is the fifth? So this is the fifth one. Enter. So fifth one is connected here. 5 is connected to the 11th. So you connect to the 11. This is the 11. The front pitch, where you are going to connect the, it should be connected to the 6th. So you are going to connect the 6th. Now 6th is connected to where? 6th is connected to 12th. No? 12th connected. This is the 12th connected. Now 12th is connected. Now 12 plus 5, 17th. You are going to connect to the 17th here. Where is the 17th? So this is the 17th. Okay, 17th conductor. Now 17 should be connected to where? 23. The 23. So 23 should be connected to front pitch. So where we are going to? 18. So we are going to connect 18, this one. So 18 is connected to 24, last conductor, this one. So this is the final position. Okay. So dear students, so what the current direction is? This one, reverse here. So this is the R phase. Okay. So this is a Y phase, this is a B phase. These are the all connections. So your aim is to draw these lines based on our table. Okay. Any confusion? No confusion. So based on the, just we follow the our winding table. Okay. So this is your final diagram. Okay. Now let us see the animation also. Now this is a, let us see the one by one phase. Let's only we will see the R phase based on the table. So in R phase, what we have to, so 1, you can say the should start as slot 1, conductor 1, 1 should be connected to the 7th and 7th should be connected to the back pitch 2, 2 should be connected to the 13th. Okay. So where? So that is equal to 8th and 8th should be connected to the, this one under one pole is over. Next is connected to the another north pole, south pole. So it is connected to the under 13th. 13th is connected to the 19th. 19th is connected to the 14th. 14th is connected to the 20th. So 20th is the finishing conductor. This end for the R phase. Okay. For R phase winding only, I connected such a way that no need to draw this one. Just you draw the all at a time. For the easy understanding purpose, I created this part. Okay. In north pole 2 slots, south pole 2 slots, and north pole 2 slots, south pole 2 slots. How it is connected, you can see here. Similarly, you can see the Y phase also. So Y phase started from the third slot. So start third slot, connect to the, so 3 to 9, 9 to 4, 4 to 10, and 10 to 15, and so we are going to the 15. Okay, another batch 15 to 21, and 21 to 16 front pitch, and 16 plus 6 is equal to 22. Okay, so 22 is the final, this one. Okay, so final this one, we are going entering and leaving. So but in this case the current direction you can see here, so you have to give the connections input from here and leaving here, okay, to maintain the 120 degrees apart. Okay, this is the Y phase. Similarly, B phase. So B phase also same thing. So started, the slots is allotted, so from 5th and 6th. So start the 5th and connect here. So 5 plus 6 is 11, 11 minus 5 is equal 6th, and 6 plus 6 is equal 12th, and 12 plus 5 is equal 17th. You have to go to another batch. Now 17 plus 6 is equal to, we are going to connect is the 23, 23 minus 5 front pitch, we are going to get the 18, 18 plus connected to the 6, that is the 24, the 24 is the final finishing. So these are the each phase I divided for easy understanding purpose. No need to draw this one. So you draw the simultaneously only one diagram. Okay. Now we combine the all this R phase, Y phase, B phase. Let us see that is also. So now based on this one, so let us start. These are the, please observe once again dear students. What are this one? These are the all parallel lines and the equal distance. Okay. After that, indicate the all numbers top and bottom. After that, place the poles equally. Then indicate the directions, assume the directions in the conductors under the influence of north pole, north pole and south pole. Okay. So now start the R phase. Okay. R phase is connected to the here under the north pole first slot. At a pole pitch, it is entered connected to the back pitch at a 7th slot. Okay. So next it is connected to the front pitch as a 5 minus 5 is connected to the second slot, second conductor, and it is connected to the 9th once again, and 9 is connected here. So another batch north pole, south pole. So it is connected to the 13th, and 13th is connected to the 19th, and 19th is connected to the front pitch is the 14th, and 14th is connected to the, so that is equal to 20. Okay. So that is connected to the ending. Starting and ending we connected. One phase is completed. Next another phase. So here conductor third slot we entered the Y phase, and back pitch plus 6 we are going to the 9, and 9 plus 9 minus 5 is equal to 4, 4 plus 6 is equal to 11, and 11 plus 5 is equal, we are going to the, so 15th, and 15th plus 6 is equal to 21, 21 minus the 5 is equal to 16, 16 plus 6 is equal to, we are going to get the, so this one, and this is the final. Okay. So 22 is the final. Next another phase, B phase, and it's connected similar way. Okay. So dear students, these are the final winding diagram animation for you. Okay. Very easy dear students, just you listen it. But in the current direction you have to indicate the R phase here. So indicate this current direction should be remember. Okay. So this is our final winding diagram dear students. Okay. So where we are going to use this winding, let us see. So this winding we have used in our AC motors. So this is our AC motor. This winding is nothing but this one. Okay. So dear students, this is a very easy and simple. Okay. So, let us conclude what we have seen in this class. We have seen, so what is the difference between the DC winding and AC winding. At the same time, we have seen the what is a single phase winding, what is a three phase winding, how these three phase windings slots are distributed under each phase, how we are going to maintain the 120 degrees apart between the phases. And based on this one, I given one case problem. We calculated what is the pole pitch, what is the front pitch, what is the back pitch. Based on this one, we have drawn one distributed conductor distribution table. From that, we are prepared one winding table with the help of the back pitch and front pitch. And based on the back pitch and front pitch, so we prepared the winding table. The winding table used to connect the end connections in our winding diagram. So, this is a final winding diagram, dear students. Please do it in your drawing sheet with the help of your drafter. Okay. So, thank you for listening my class, dear students.